hi again everyone, Chris Tisdell here again. Thanks for watching. Now in this particular presentation I'm going to continue my series of videos on calculus, and I'm going to show you how to integrate when the method of partial fractions fails. And I'm going to step you through an example that might occur, say, in a second course in calculus. So let me share my screen with you and we can get started. Okay, so the first thing you'll notice is the font is massive. If you're watching on a mobile device, I'm trying to make my presentations better equipped for mobile devices. So please let me know your experience in watching this video. All right, we're asked to calculate the following integral that we've denoted by this I. Okay. All right, so it's a rational function. You've got a polynomial divided by a polynomial. How do you actually compute the integration? Well, you'll notice that x squared plus 6x plus 10 doesn't factor over the real numbers. So you know, if you wanted to do the method of partial fractions, you would try to factorize this denominator into linear parts and then use the method of partial fractions. It's not available here. Okay, so what do we do? What do we do? Okay, well, here's the idea. This is almost the derivative of what's down here. Okay, so what we're going to do is massage or manipulate the numerator so that it is exactly the derivative of the denominator. Then we can use logarithms and we'll be left with a bit that's left over. Okay, so what I'm going to do is go, okay, what's the derivative of the denominator? If I just forget about the top bit and differentiate everything with respect to x down here, I'll get 2x plus 6. So what I want to do is try to make this top bit 2x plus 6. Okay, so I'm going to manipulate it. Then I'll be able to use the logarithm function, and I'll have an extra bit left over. All right, so how do I do it? Well, let's just write 2x plus 6 up here, and we'll get to the rest of it a bit later. Okay, that's where I want to go. Now, what's the difference? Well, that's x, and that's 2x. Okay, so I have to manage away that 2, and I've got plus 0 up here, and I've got plus 6 there. So let's do that first. I'm going to put a minus 6 in there, so we've got rid of the constants. And what do I do about this 2? Well, I can multiply the whole thing by a half. Okay, that hasn't changed anything. It's just changed the numerator and this a little bit. All right. Okay, so let's break this up into two integrals. Now you'll see why I do this in a minute. Yeah. Okay, so I'm just going to break it up into this part now. I'll just keep the one integral sign for this. Okay, just squashed it in. All right, now what we can do down here, the numerator is exactly the derivative of the denominator. Yeah, so there is an idea whereby if you are integrating a function where the derivative of the denominator is the numerator, okay, then it's just the natural logarithm of what's on the bottom, the denominator. Okay, and I leave off the plus c. So this is the situation that we got down here, where f of x is down here and the derivative's up here. So this integral will be the logarithm of x squared plus 6x plus 10, absolute value. All right, over here it's a little bit more tricky. Okay, we'll get to that in a sec. So it's a half of the logarithm of what's down here, the denominator. Okay. Now, let's expand this out. The half and the 6 will cancel. I'll write this down as a second line now. So I can actually take that out the front and have a 3 there. Okay, so the question now is, I've got the first part. What do I do with that? I can't factor the bottom, but what I can do is complete the square. Okay, I can complete the square and then use something like an inverse tan on the integral. Okay, so how do you complete the square? Well, you look at the coefficient of x, it's positive 6. You take half the coefficient, you add it, or you square it, you add it, and you take it away. And that will form your square. Okay, let me show you that on a separate sheet of paper. All right, so x squared plus x squared plus 6x plus 10. Okay, that equals, well, let's take half of that. So that's 3. Square it. Add it and take it away. Now, I've written it in this form for a special reason. That now is can be written as a square. And I've got 10 minus 3 squared, which is 10 minus 9, which is 1. Okay, so the green is this, and you can verify that by expanding the bracket. And 10 minus 3 squared is just 1, or 1 squared, if you like. The other way to do it is just write 10 as 9 plus 1, and you'll get this. Okay, that's completing the square. All right, so let's write this as this, and then I can actually use inverse tan. So the ln stands for natural logarithm, by the way. Okay. So I'm going to write this as what I had on the other page. Okay, 1 squared, if you like. Now, how do I integrate this? Well, this is just going to be the inverse tan of what's in here. We've got a linear function in here. It's going to be the inverse tan of this thing here. Think of this as 1 squared, if you like. Okay, so let's continue on. We're almost finished now. All right, minus 3 inverse tan of what's in the brackets. Okay, and let's put in the constant of integration. Okay. All right, so this last bit from here just comes from the following. Let me push that up. That is just 1 on, where a is a constant here. And you can have u here if you wanted to. Okay, and I'll leave off the constant of integration. Okay, there we go. All right, so this is our value of I. Okay, so this thing becomes this, where C, I guess I should write that down, where C equals a constant. Okay. All right, so let's recap. Let's recap that solution method. The idea is to show how to integrate these rational functions when the denominator doesn't factor over the reals. So let's just recap. This doesn't factor. What we wanted to do was try to get the denominator to be the derivative of, the numerator to be the derivative of the denominator. Okay, the derivative of what's down here is 2x plus 6. So I wrote that down and then I massaged it. And I broke it up into two integrals. This will lead to a logarithm. This will lead to an inverse tan. And we just went through the motions and we got down to that. Okay? Okay, so I hope you've enjoyed this presentation. Hope you found it useful. If you have any comments, any questions, I'd love to hear them. You can send me a message or leave a comment. Please join me for more presentations in the future where I'll be trying to make my presentations even more massive, font and mobile friendly. See you later.